Let's move on to the chain rule. We're going to cover a lot of examples. The first formula you need to be familiar with is the derivative of the composite function f of g of x. A composite function is one where you have one function inside of another. Notice that g is inside of f, which makes it a composite function. So the first thing you need to do is differentiate the outside portion of the function, that is f. And you need to keep the inside the same, and then multiply it by the derivative of the inside. That's the main idea behind the chain rule. If you follow this process, you're going to get the answer right. So let's say, for example, if we have a function u raised to the n, where u is another function in terms of x. Using the chain rule and the power rule combined, it's going to be n times u, you have to keep that the same, raised to the n minus 1 times the derivative of what's on the inside. That's the general power rule formula with the chain rule combined. So never forget to multiply by the derivative of the inside function. So let's use an example. Let's say if we want to find the derivative of 5x plus 3 raised to the 4th power. So the first thing we're going to do is we're going to move the exponent to the front. So it's going to be 4, and then keep the inside stuff the same, times 5x plus 3, subtract the exponent by 1, 4 minus 1 is 3, and then multiply by the derivative of the inside. The inside function is 4, it's 5x plus 3. The derivative of 5x plus 3 is just 5. And so that's the answer. We can multiply 4 and 5, that's going to give us 20. So it's 20 times 5x plus 3 raised to the 3rd power. So that's the final answer, fully simplified. Now let's work on some more examples. Find the derivative of x squared minus 3x raised to the 5th power. So first, let's bring down the 5. So it's going to be 5, and then keep the inside function the same, and then subtract the exponent by 1, so this is 4, and then multiply by the derivative of the inside. The derivative of x squared minus 3x is 2x minus 3. And so that's the answer. Once you get used to the process, it's not that bad. Here's another example that you can try. Find the derivative of sine of 6x. The derivative of the outside part of the function sine is cosine, and you got to keep the inside function the same. Then you multiply it by the derivative of the inside function. The derivative of 6x is 6, so the answer is simply 6 cosine 6x. Now what is the derivative of cosine x squared? So first, differentiate the outside part of the function, cosine. The derivative of cosine is negative sine. Now the inside part of the function has to remain the same, that is the angle of cosine. So it's going to be x squared. And then differentiate the inside function, x squared, which is 2x. So basically, you're working away from the outside towards the inside. The final answer is negative 2x sine x squared. Find the derivative of tangent x cubed. So first, let's differentiate tangent. The derivative of tangent is secant squared, and the inside function has to remain the same. Next, differentiate the inside function x cubed. So that's 3x squared, and it's always multiplication. So it's going to be 3x squared secant squared x cubed. As you can see, it's not that bad. Here's another problem. What is the derivative of secant 4x? The derivative of secant 4x is going to be secant tangent. That's the derivative of secant. Now the inside function has to remain the same for secant and tangent. Next, we need to differentiate 4x, so it's just going to be times 4. And so that's the solution. What is the derivative of ln x raised to the 7th power? Try that problem. So this is going to be 7 keep the inside part the same, and then subtract the exponent by 1. So 7 minus 1 is 6. Now we got to multiply by the derivative of the inside function. The derivative of ln x is simply 1 over x. So the final answer is 7 ln x raised to the 6th power divided by x. What is the derivative of the square root of x cubed minus 7? Take a minute and work on that example. The first thing I would do is rewrite it. So this is the same as x cubed minus 7 raised to the 1/2. And so that's going to be equal to 1/2. We got to bring the exponent to the front, keep the inside function the same, and then subtract the exponent by 1. 1/2 minus 1, which is 1/2 minus 2 over 2, that's a negative 1/2. And then we got to multiply by the derivative of the inside. The derivative of x cubed minus 7 is simply 3x squared. So we could bring this back to the bottom since it has a negative exponent. So it's 3x squared divided by, we have a 2 on the bottom, 2x cubed minus 7, and now the exponent is going to change from negative 1/2 to positive 1/2. And now we could put it back in its radical form. So it's 3x squared divided by 2 square root x cubed minus 7. And so that's the final answer for this problem. Find the derivative of 1 divided by x squared plus 8 raised to the 3rd power. So first, let's rewrite the expression. Let's bring the variables to the top. So this is x squared plus 8 raised to the minus 3. And now we can use the chain rule combined with the power rule. Let's move the negative 3 to the front, and let's keep the inside function. Let's rewrite it exactly the way we see it. And then let's subtract this by 1. Negative 3 minus 1 is negative 4. And now let's multiply by the derivative of the inside function, which is 2x. So now let's take this term, move it back to the bottom. So we have negative 3 times 2x, which is negative 6x on top. And on the bottom, it's x squared plus 8 raised to the 4th power. And so that's all we need to do for this problem. So for some examples, you need to rewrite it before you find the derivative. Now what if we have a trig function inside another trig function? Find the derivative of this function. So first, we need to differentiate the outside function, sine. The derivative of sine is cosine. Now, what's inside of cosine? Since cosine came from sine, everything inside of sine is going to be the stuff inside of cosine. So that's tangent x to the 4th. Now let's move on to tangent. The derivative of tangent is secant squared. And the stuff that's inside of tangent is going to be the stuff that's inside of secant squared. So that's x to the 4th. And then we got to move on further towards the inside. The derivative of x to the 4th is 4x cubed. And so that's the answer. How about this example? Find the derivative of sine raised to the 5th power, tangent, cosine, x cubed. The first thing I would do is rewrite the expression. So this is sine, tangent, cosine, x cubed, all raised to the 5th power. So first, let's deal with the exponents. Let's use the power rule. So we got to bring the 5 to the front and keep everything inside the same. So always start with the outside portion of the function, which is going to be the exponents in this case. And then subtract the exponent by 1, so it's going to be 4. Now let's work our way towards the inside. So we got to differentiate sine. The derivative of sine is cosine. And the stuff inside of sine is tan cosine x cubed. So we got to put that here. Now let's move on to tangent. The derivative of tangent is secant squared. And the stuff inside of tan is cosine x cubed. So hopefully you're seeing a pattern with the way we're finding the derivative of everything. So now that we're done with tangent, let's move on to cosine. The derivative of cosine is negative sine, and the angle of cosine is x cubed, so that's going to be the same here. And then let's move on to x cubed. The derivative of x cubed is 3x squared. So that's the answer. And then you can combine terms. You can multiply 5 and 3 to get 15. What is the derivative of cosine raised to the 7th power of sine of secant x squared? So try that problem. So first, let's rewrite it as cosine of sine of secant x squared. And let's put the 7 in its exponent position. So let's use a power rule. Let's bring the 7 to the front, and let's keep everything on the inside the same. And then subtract the exponent by 1, so this is going to be 6. Now let's find the derivative of cosine. Let's work our way towards the inside. The derivative of cosine is negative sine. And the stuff inside of that is sine secant x squared. So now we got to find the derivative of sine. The derivative of sine is cosine, and the stuff inside of sine is secant x squared. So now we got to find the derivative of secant. So that's secant tangent. So it's going to be secant x squared tangent x squared. And the derivative of x squared is 2x. So whenever you have multiple composite functions, just work your way from the outside towards the inside, and everything is multiplied by each other. And then when you're done, simply collect terms. So we have a 7, a 2x, and a negative. So you can move that to the front and write it as a negative 14x if you want to. Here's the next problem. Find the derivative of x cubed times 4x plus 5 raised to the 4th power. So what we have here is a product rule. We could say that this is f and this is g. And for g, we have to use the quotient rule. I mean, not the quotient rule, but the chain rule. So using the product rule, we need to differentiate the first part, f. The derivative of the first part is 3x squared, and we need to keep the second part the same. So we just have to rewrite g. Plus, now we need to keep the first part the same. Now for the second part, we need to use the chain rule. So let's bring the 4 to the front. Let's keep the inside stuff the same, and subtract the 4 by 1. Then multiply by the derivative of the inside function, which is 4x plus 5. The derivative of that is 4. So now let's simplify. So the first part, we don't really need to change anything. We can just leave it like this. Now for the second part, we can multiply 4 and 4. That's 16. So this is 16x cubed times 4x plus 5 raised to the 3rd power. You can leave your answer like this, or if you want to, you can take out the GCF. We can take out an x squared, and we could take out 3 4x plus 5s, or basically 4x plus 5 to the 3rd power. So this is gone. We took 3 of these, 1 is left over, and we have a 3 left. So this is going to be a 3 times 4x plus 5. And this is gone. We took out all 3 of these. Well, there's an x left over and a 16, so plus 16x, because we took out an x squared. Now what we can do is basically simplify what we have here. So this is x squared, 4x plus 5 to the 3rd power. And let's distribute the 3. So 3 times 4x is 12x. 3 times 5 is 15 plus 16x. Now let's add 12x and 16x. So the final answer is x squared times 4x plus 5 to the 3rd power, and then 28x plus 15. So that's the solution. Let's try one more example. Let's find the derivative of 2x minus 3 divided by 4 plus 5x raised to the 4th power. So this is a chain rule and quotient rule problem. So first we need to bring the exponent down and keep the stuff on the inside the same. And then subtract the exponent by 1. Next, we need to multiply by a derivative of the inside. So that's when we have to use a quotient rule. So f is 2x minus 3, and g is 4 plus 5x. F prime is 2, g prime is 4. And the formula for the quotient rule is it's gf prime minus fg prime over g squared. So g is 4 plus 5x. F prime is 2. And f is 2x minus 3. G prime is 4, divided by g squared, which is 4 plus 5x squared. So as you can see, this is a long problem. So let's simplify what we have on the right side. If we distribute the 2, it's going to be 8 plus 10x. And if we distribute the 4, it's going to be negative 8x. And then negative times negative 3 times 4, that's positive 12. Divided by 4 plus 5x squared. And then this part is going to be the same. So let's simplify the numerator. So first, we can add 8 and 12. So that's going to be 20. And then 10x minus 8x, that's positive 2x, divided by 4 plus 5x squared. Now, this thing, we could distribute the 3 to the numerator and then denominator. So we can write it like this if you want. 2x minus 3 cubed divided by 4 plus 5x squared. The reason why I did that is because I can now combine these two terms. This is supposed to be cubed, not squared. So now what we have is 4 times 2x minus 3 to the 3rd power. And I'm going to take out a 2 here. So if I take out a 2, it's going to be x plus 10 over 4 plus 5x raised to the 5th power. 3 plus 2 is 5. So the final answer is 8. 4 times 2 is 8. Times x plus 10 times 2x minus 3 to the 3rd power divided by 4 plus 5x to the 5th power. And so this is the final answer.